Hi there, it's Jason Gorman from Codemanship with the second in our series on test-driven development for Python programmers. If you missed the first video, we looked at the basic 3 steps of the test-driven development cycle. You write a failing test, you write the simplest code to pass that test, and then if necessary, you refactor the code to make it easier to understand and easier to change going forward. If you missed that first video, then I strongly recommend you have a look at that first. There'll be a link in the description below. In this second video, I'm going to be talking about 3 habits that I found very useful to get into when you do TDD that make it more effective and more sustainable. The first of the habits we're going to be looking at is why I think it's a good idea to start by writing the test assertion and work backwards to the setup. The second habit we're going to be looking at is why I think it's a good idea to run the test and see that it does indeed fail before you make it pass. And then the third habit we're going to be looking at is how many reasons should our tests have to fail? How many questions should they ask? I found over the last 20 years that it works best when your tests only have one reason to fail. We'll be demonstrating each of these 3 habits with a simple example and talking about why I found them to be helpful. Okay, now I'm going to be using the built-in unit testing framework, which is just called unit test, that ships with Python, so we don't have to import anything using pip. And I'm going to be writing tests for a DVD library. So the idea is that members of this library, it's a community library, and they can donate DVDs that they don't want to own anymore. Maybe they want to share them with other members of the library. And when they donate a DVD, there are 2 things that need to happen. First of all, that movie needs to be added to the catalog, and then we need to register a single rental copy for that movie so people can borrow it. So 2 things that need to happen. I'm going to start by writing a test fixture. Remember, we write a failing test first. You will probably note, as in the first video, that I am putting it in a separate folder from the root folder, in a test folder, so that my tests are separate from the source code. That's another good habit to get into. And I've got a little feature here that I can use in PyCharm that will automatically generate a test file for me. So let's use that. So these are tests for donating a movie to the library. Let's generate a test file, and you'll see, let's just point out if you're unfamiliar with unit test, we import that ships with Python, so we've already got it. We just need to import it for our file here. You'll note down the bottom here, and I didn't use this in the first example, but it's generated it here for me here, is it generates sort of a main method at the bottom there for this file so that I can run all of the tests just by running this file using Python. But we don't need to worry about that because we're going to be using the IDE to run our tests for the time being. Okay, now let's name this test fixture. It's just a class that inherits from test case. So unit test, the test runner knows that this class has got test methods in it. And let's call this donate movie test. Nice, easy to understand name. And a test method, a method that's going to contain our test code, is just a plain method that starts with test underscore. So test donate movie. We'll talk in a minute why that's probably not such a good name, but we'll get to that. Now, habit number 1. In the first example, and a lot of developers do this, and it's by no means the worst thing you can do, but I found it to be helpful to do it the other way around. In the first example, I started by writing setup for my test. Let's imagine we've got a movie. Writing the setup for my test first, and working my way towards the assertion. Now, the risk of doing that is that you end up with the wrong setup. That is, you haven't got what you need to ask the question that you want to ask. TDD tests are all about describing the what. What should the code do? So let's start with the what. Let's start by asking the question we want to ask. So we write an assertion first, and we're going to assert that our movie is in the library. So let's imagine the library has a catalog. Okay. And now we're going to work backwards from the test assertion, creating the setup that we need so that we can run this test. Okay, so there's no such class as movie, so let's create that. Now we need a library. Okay, no such class as library, so we can create that. So you can see that we're working our way back towards, let's donate the movie, and our library is going to need, it's going to need a collection of some kind called catalog. It can hold, let's just make it a self, yep. You're not working in Java now, Jason. Okay, so that's our test. We started by writing the assertion. We asked the question, is the movie in the catalog? And then we worked our way back to the exact setup that we needed to ask that question. So let's run this now before we see it pass, just to check that that assertion fails. So this is very, very useful. This is habit number 2. Before you make your test pass, run it. Oh, there's something else missing here as well. Silly Jason. It's a good idea when you're working in scripted languages to run your tests often, or run your code often, so you can see why it's failing. So our assertion at the moment is failing, this assertion, because the movie is not in the catalog. And it's important to see that so that we can have confidence going forward that if we were to break this code at any point in the future, this test would fail, this test would catch it. So not only does it act as a specification for now to tell us what code we need to write, in the future it's going to protect us from regressions. It's going to protect us from when we break the code so that we can run our tests and find out straight away. So that is a very useful side benefit of doing test-driven development. Because we're only writing code past tests, theoretically that means all of our code will be covered by tests, but that doesn't necessarily mean that all of our tests will be good tests, that they will catch errors. So test your test by running it and making sure that the test assertion fails. Not some unhandled exception because we haven't declared something or because something's null. See the test assertion fail. If the result was wrong, would this test catch it? Very, very important. So test your test, run it to see that it does fail before you make it pass. Then, of course, we do the simplest thing we can think of to make it pass, which in this case is just to add it to the catalog. So let's append our movie. And now our test is passing. Now the test is passing, it is time to think about whether we need to refactor. There's a few things here that are bugging me. First of all, these classes are solution code and they don't belong in the test. So let's move these to their own files in the root folder away from the test code. So that can have a file called movie. And as soon as I've done that, immediately rerun that test. Make sure I haven't broken anything. Now that we have confidence that this is a good test, okay, and let's move library into its own file in the root folder, and immediately we run our tests. And there's one more thing that's bugging me here. I'm not really sure that I want to expose the catalog. That should be an internal detail of library. So let's encapsulate that. First of all, we'll create a method for checking if the library contains a certain movie. And as soon as we do that, we run that, and yep, lovely. And what we want to do now is we want to move this method from this test fixture to library. There is no automated way of doing this in PyCharm, and that's because we don't have the type information we need about these objects to automate that. So what we're going to do is we're going to do it manually. First of all, we're going to cut this, and we're going to replace. So we're going to turn the invocation of this method around from self to the library itself. And then immediately, as a single move, as a single transaction, if you like, we're going to paste our method back into here, and we're going to update the references so it's not the library catalog itself. So we've turned that around. And hopefully now when I run my test, it still works. So a bit of encapsulation going on there. That's always a good thing. Okay, so that's the first question we wanted to ask. Is the movie added to the library? Is it in the catalogue? The next question we want to ask is about the rental copies. So our movie should have exactly one copy. And let's just declare what we need for this to fail. Let's see it fail. So let's make the copies 0. So before the movie is added to the library, there are 0 rental copies. Okay, and now our assertion is failing. Let's take a look and see why it's failing. Okay, so expected 1, but the actual was 0. So it is useful to see the test fail so that we know it's a good test, that it will protect us from regressions going forward as we change our code. But also it is useful to see the failure message to make sure that it is meaningful, that people can look at that and go, oh, I see what's happened here. So in this case, I think we've got a good failure message. Expected 1, but is actually 0. And then we just do the simplest thing we can when we donate our movie. So let's just add, this is the quickest thing I can think of. Let's add copy to the movie. And that should make our tests pass. Okay, so write the assertion first and work backwards to the setup so that you end up with the setup you need to ask that question. Run the test and see that it does fail when the result is wrong, which means you'll have to have enough implementation to see the test assertion fail, but only just enough. Then when you've done the simplest thing to pass the test, it's time to think about refactoring again. Now, again, copies here, I'm not really sure that the library should know about the copies. So we're going to encapsulate this. Let's call it, I don't know, add copy. And immediately run my test. And again, we want to move add copy. So we need to do this as a single move. Let's cut that. Let's change the target. So the movie is no longer the parameter. It's now the target. And here we need to paste in our method. We don't need that parameter anymore because we're actually referring to this object. So we're referring to self. So another bit of encapsulation going on there. Lovely. All our tests are passing. And now there are different schools of thought about fields, about whether you should access fields in tests. I'm not too worried about that. I'm not too bothered about creating getters, for example, to access fields. But if that's your house style, then by all means do that. Now, in real production Python, I'm in the habit of making objects immutable. Therefore, copies would always be the same value. So it wouldn't be too much of it wouldn't be a big deal if it was just exposed in this way. But in this case, it's mutable, and therefore we maybe want to think about encapsulating it. Let's just quickly do that. So get copies. So you're beginning to see this process of extracting and moving methods. Again, so you extract a method, and then you turn the invocation around, and then you go in there and change the object we're referring to from the parameter to the okay. Wants me to add a new end of line. Bit of formatting going on here. I do enjoy that aspect of Python. And now we can actually, let's just quickly run that now that we've done it. And now we can rename this to internalize it as per the naming convention. And while we're in there, we're no longer exposing the catalog, so we can do the same for catalog. So let's rename catalog to underscore catalog. Okay. There, that's all nicely encapsulated now. Okay, now back to our test. The final habit is all about how many reasons our tests have to fail. Now, this test asks two questions. There's two reasons this could fail. It could fail because for whatever reason the movie hasn't been added to the catalogue, or it could fail because for whatever reason we haven't actually added the right number of rental copies. And as your tests grow, we tend to find that tests that are asking multiple questions that have multiple reasons to fail can become a bit of a burden, because when the test fails, it's less obvious what's gone wrong. They're less good at pinpointing the error. So as we move forward, I find that it's a good habit to get into to make sure that each of your tests only has one reason to fail. So when it fails, it immediately pinpoints the problem. And that way you spend a lot less time in the debugger wondering which part has gone wrong. So what we're going to do to finish off is we're going to refactor our test code. Remember, test code is production code 2. It needs to be maintained. So let's refactor our test code to make these tests more specific, and also to make it easier going forward to add new behaviors. So first of all, what I want to do is I want to extract what's called a setup method. So we're going to end up with two tests that have the same setup. So before I extract that second test, I'm going to create a shared setup. That's quite easy to do in unit test. But before I do that, I need to turn these local variables into fields of this test fixture, and you'll see why in a minute. So let's have a, you don't want to extract a method, we want to extract a field. There we go. Can it perform refactoring on selected elements? Sure you can. Okay, so let's replace all the occurrences of that. In the current method, there we do that, and immediately run tests. So movie is now a field. Let's make library a field. Okay, and immediately we rerun our tests, and you'll see in a minute why I've done that. What I'm going to do is all of this code here, I'm going to extract into its own method called setup, and that method doesn't return any data and it doesn't take any parameters. So it means that the objects it creates need to be fields. Now this is going to override the setup method of test case, and that's exactly what we want to happen. Just rerun our tests. Now that we have a method called setup, unit test, the test runner knows that this is a method that should be run before every test. So I don't actually need to invoke it. I don't need to call it inside the test, because the test runner will do that automatically. Now that we've got that, we can very easily extract a second test. Let's just do that. And let's call that test copy added. Rerun our tests. But because this begins with test underscore, the test runner will go, well, that's a test in its own right. So I don't need to invoke that explicitly either. So let's rerun that. So now we have two distinct tests. One which is about whether or not the movie is added to the library. Let me just rename movie added to library. Quickly rerun that. So we have two unique tests that are about two distinct outcomes. They're not about the action, they're about the outcomes. And each test is about one single outcome. So they're very specific. It also means that if we want to understand how our movie donation works, we could just look at the names of our tests. And that would say, well, these are all the outcomes that we're expecting. So one outcome per test is a good pattern for test design, but it also helps us in terms of writing tests that pinpoint problems very, very specifically. So there you go. There's three habits that are worth getting into. Habit number one, write the test assertion first and then work your way backwards to the setup. Now that takes a bit of getting used to, but you tend to find that you almost always end up with exactly the setup you needed to ask that question. So, and it also turns your thinking around. So now you're thinking about the what and not the how. And the second habit is run your tests and make sure that they do fail when the result is wrong. So see the test fail, specifically see the test assertion fail. So you need to write just enough code to run the test and see the assertion fail. And finally, try to end up with tests that have one outcome or one question per test. Each test should only have one reason to fail. They act as better documentation, but also importantly, they act as better regression tests because they pinpoint problems more accurately. Okay, so there's the 3 habits. Remember, in the description below, there'll be a link to the first video. And I recommend that you watch that first. And if you've already watched this whole video, it's probably too late, Jason. But there you go. If you didn't watch the first video, it's well worth going back and having a look. And I'll also put a link to the documentation for the latest version of unit test. So if you've not come across this unit testing framework before, it ships with Python, so it's very, very easy to get started with. Okay, until the next video.